Welcome to our video tutorial here involving rational function and rational equation word problems. So we see the problem in front of us. We're going to look at two different problems actually. If you would like to hit pause to try this problem out before we discuss it, please do. But what we're going to do is we're going to set up the table like we looked at in Unit 1. We're going to set up the table like we looked at previously. So, in this problem, the titles are object or person, either one. The rate, the time, and the distance or work. Here we have Walt and we also have Whitney. So those will be the two people in the problem. Now for the labels here. For rate, we're talking about the number of jobs each of these individuals completes per hour based on this problem. Remember, this is the key to this type of problem right here. We have to look at it as the number of jobs per amount of time. Well, that tells us what our time is. Our time will be measured in hours. And then when we do the factor labeling, the hours cancel and our final unit is just going to be the work measured in the number of jobs. So with Walt, Walt completes one job in 14 hours. So his rate will be 1/14th. Whitney, we don't know how long it takes Whitney. That's what we're trying to find. Say it takes Whitney X hours to paint the auditorium working by herself. Well, then that would mean that she does one job in every X hours. The key to this problem is to realize that we have how long it takes them working together. So here it's taking them 9 hours working together, and this table is based on the assumption on some level as though they are working together. So Walt would take 9 hours and Whitney would take 9 hours because that's how long it takes them cooperatively. Then, don't forget, rate times time equals distance. So here, the distance or work for Walt will be 9/14ths, just multiplying those things together. And for Whitney, it'll be 9/x. The key then to the problem in order to finish this off is that we're going to realize we want one complete job to be done. So when we take Walt's component, which is 9/14ths, with Whitney's component, which is 9/x, we get one job. Now here's where it ties into our rational equations. We are going to need to multiply through by the least common denominator in order to solve. Here, that's pretty easy to identify. It's going to be 14 times x on both the left and the right hand sides. Over here, the 14's cancel, so we have 9x. Then the x's cancel. So whatever 9 times 14 is, that's what we will put in that blank, which is 126. And over here, 1 times 14x is just 14x. Get the x's on one side, get the number on the other side. And then we will need to divide by 5 to finish off this problem. Decimals are fine for word problems, so we get 25.2, and the unit of measure would be hours. So it would be 25.2 hours. Now if we had asked for hours and minutes, it would have been 25 hours, and to figure out the number of minutes you would have taken the decimal number of hours and multiplied it by 60 to get minutes. So 0.2 times 60 would tell us that we were looking at 12 minutes. I would be clear when asking a question what we were looking for, but in this case it would take Whitney 25 hours and 12 minutes working by herself to paint the auditorium. Next, we will look at one more problem. It's on your screen. Perhaps you want to hit pause and try it out before we discuss. Now that we're discussing, we're going to set up our table. In this problem, we're talking about the trip to vacation and then the trip home from vacation. Let's look at the word problem. We know that Tiffany drove 720 miles to her vacation and 720 miles home from her vacation. Not only does it tell us the number, but it tells us the unit, which is miles. Keep in mind that rate times time is equal to distance. We don't know any of her rates. Let's call her rate there x. Now, her rate home is 12 miles per hour slower. So one thing this tells us is that the unit for rate is miles per hour, which means the unit for time has to be hours. But if it's 12 miles per hour slower, we would take the x and we would subtract 12 from it because that would make it slower. Now the other key to this problem and how we need to think about these rational word problems is the time column. If rate times time equals distance, if rate times time equals distance, then to get time by itself, we would take distance divided by rate. And that's what we will do. So the distance for the trip to the vacation is 720 divided by the rate, which was x. The distance from the trip was 720 divided by the rate, which was x minus 12. Now our table's filled in. And here's how we will polish it off to get the equation. We know that the return trip took 9.5 hours longer. So the time on the way home, 720 over x minus 12, is bigger. Subtract the smaller number, which was the time it took to get there. Remember, we were going faster, so it was less time to get there. And their difference is going to be equal to the number we have, which is 9.5. Now there's the equation we need to solve. So to get the rational equation the way we need it, we're going to multiply both sides by x times x minus 12. Over here on the left, the x minus 12's cancel and we get 720x. Then the x's cancel and we get minus 720 times x minus 12. And over here we get 9.5 times both of those things, so we'll FOIL it out, and it's x squared minus 12x. Now here's another thing. I don't really like that 9.5. So what if we doubled both sides of this equation? That would get rid of the decimal. You don't have to do this, but when we double, we'll get 1440x minus 1440 times the quantity x minus 12 equals, now 9.5 times 2 is 19, times the quantity x squared minus 12x. We will continue. So we get 1440x minus 1440x, make sure we're distributing here, plus whatever 1440 times 12 is, 17,280. Equals, over here we have 19x squared minus whatever 19 times 12 is, looks like 228x. Now look at what happens over on the left. Two things cancel. Those x terms are gone. Get rid of them. So we have 17280 equals 19x squared minus 228x. Get 0 on one side, get everything else on the other side. So we'll subtract the 17,280. Now one thing I might look at right here is, are those numbers divisible by 19? 228 is divisible by 19. Nice. 17,280 is not divisible by 19. Ooh, that's not quite so nice. But sometimes it's good to see if you have a greatest common factor that you could divide by. So if you cannot find a number that, like 19, dividing through evenly, then we have to turn our attention to the quadratic formula. So x would equal negative b, which in this case is 228, plus or minus the square root of b squared, negative 228 squared, minus 4 times a times c, oops, that c should be a negative 17,280, all divided by 2 times a. Now in this problem, decimals are fine. So we're going to type, first of all, the square root item. So I'm going to do 228 squared minus 4 times 19 times negative 17,280. And that looks like it's going to be 1365264. So 228 plus or minus the square root of 1365264 all over 38. Now we could just type that into our calculator. So if I type the numerator 228 plus that square root, divide it by 38 at the end, on the one hand, we're getting that's equal to 36.75, rounded to 2 decimal places. Or, now I'm going to type it in. That first one was when we used the plus option. Then I'm going to type it in as if we were using the minus option. So when we type it in, 228 minus the square root of 13,65264 divided by 38, I'm getting negative 24.75. Now we cannot drive a negative miles per hour, at least for anything that would make sense for what we're doing in this class, so that's going to be an extraneous solution. Don't really worry about it. So the answer here for x is 36.75 approximately. And the question is, what is Tiffany's average speed on the way to her vacation? Well, that's what we called x. So the answer to this problem, keeping in mind that we rounded it to 2 decimal places, is approximately 36.75 miles per hour. That would be our final answer. Sometimes it might factor, but if it doesn't, just use the quadratic formula.